I'm your host for Think Cosmos. Tonight, we are going to zoom out across the whole solar system, from a visitor that came from the deep between the stars, to traffic jams and close calls in Earth orbit, to rockets and space forces all trying to shape the next decade beyond our planet. Now settle in. Settle in. This is your November 20th, 25 Space News. Deep dive. I want you to picture the solar system as it is right now. The sun glowing at the center. Planets sliding along their orbits, circling. A web of spacecraft everywhere, from low Earth orbit all the way out past Jupiter. Now, imagine that entire fleet being told to look up and track one single object. A tiny icy body flying in from interstellar space. Not from our own solar system at all. A visitor. That is what NASA has started to do with Comet 3I/Atlas. This is only the third confirmed interstellar object ever found passing through our neighborhood after Oumuamua and Comet Borisov. 3I Atlas was discovered in mid-2025. Its orbit is hyperbolic, which means the sun will bend its path, but gravity will not be strong enough to trap it. It came from far away, and it will leave again. Because objects like this are so rare, NASA has decided to treat 3I Atlas as a once-in-a-lifetime science target. Instead of sending a new mission, which would have taken years to plan and launch, scientists are turning the spacecraft they already have. Orbiters around Mars. Deep space probes in the asteroid belt. Even telescopes that spend their days watching the sun. In a news release this week, NASA described it as the first solar system-wide observation campaign for an interstellar comet. Think about what that means. We are using robots scattered across hundreds of millions of miles, all synced up to watch the same fast-moving speck of ice and dust. Near Mars, the Mars Reconnaissance Orbiter is using its powerful high-resolution imaging science experiment camera, HiRISE, to capture close-up views as the comet sweeps through the inner solar system. Other Mars missions, like MAVEN and Mars Odyssey, are watching how the solar wind and high-energy particles interact with the comet tail. Each of those spacecraft is like a different sensor in a huge three-dimensional laboratory. But farther out, probes like Lucy, which is on its way to the Trojan asteroids near Jupiter, are also being cued to look for the comet when geometry allows. Even solar observatories such as SOHO and the Solar Dynamics Observatory may catch glimpses when 3I Atlas appears in their fields of view. On November 19th, NASA released the first long-awaited images from some of these spacecraft. They show 3I Atlas as a condensed bright core with a thin developing tail against the black sky near Mars. To the human eye, it is just a fuzzy dot. To planetary scientists, it is a treasure chest. Why does this little speck matter so much? Because interstellar comets are samples of other planetary systems that we cannot reach any other way. The ices in their cores preserve conditions from whatever star system they were born in. Their chemistry can hint at how common water, organics, and complex molecules might be out there among the stars. By comparing 3I Atlas to ordinary comets from our own Oort cloud, scientists can ask a simple but profound question. Is our solar system average? Or is it weird? If the ratios of elements and molecules in 3A Atlas are very different, that suggests other planetary nurseries produce different kinds of building blocks. If they are similar, it hints that some parts of planet formation might be universal. There is also a more dramatic possibility. Some researchers wonder if interstellar comets like Atlas might occasionally seed young planets with water and organics, not with full-blown life, but with the ingredients for life. Each passing visitor would be like a frozen care package from another star. As data from this campaign rolls in over the coming months, expect to hear more about the spectrum of 3I, Atlas, the temperature of its coma, and whether it shows any unexpected features. For now, just appreciate the coordination. Mars orbiters, deep space probes, solar observatories, all turning their eyes toward one tiny traveler that will never come back. While our robotic fleet studies that interstellar visitor, things much closer to home are reminding everyone that space is not empty or safe. Let us drop back to low Earth orbit and visit the Chinese space station, Tiangong. Earlier this year, a crew of 3 Chinese astronauts, or taikonauts, launched to the station for what was supposed to be a routine stay. But their return to Earth was delayed. The reason was not weather. It was damage from space debris. Chinese officials reported that debris had impacted part of the station complex, forcing extra inspections and repairs before the crew could safely depart. For days, international tracking networks watched for any sign of worsening problems, while the crew remained in orbit. This week, the taikonauts finally undocked, re-entered Earth's atmosphere, and landed safely in northern China. State media celebrated the successful mission, and the crew spoke about their extended time in space. Behind the public ceremony, there is a quieter message. Low Earth orbit is getting crowded and dangerous. There are thousands of active satellites, many more dead ones, and millions of fragments of debris, from paint chips to metal shards to whole rocket stages. Even a small fragment, traveling at several kilometers per second, can punch through station hulls, radiators, or solar panels. Every major space agency now spends a lot of time dodging junk. For the Chinese program, this incident adds pressure to invest more in debris tracking, and perhaps in future cleanup systems. For the rest of the world, it is yet another warning that congestion in orbit is no longer an abstract problem. It is affecting real missions and real crews. Now, shift your view again, this time to a launch pad in Florida. In the middle of November, SpaceX sent up a Falcon 9 rocket carrying Sentinel-6B, also known as Michael Freilich 2, an American-European satellite that will continue a long-running series of ocean height measurements. Why does a sea level satellite belong in a space news roundup? Because missions like Sentinel-6B show how tightly linked space technology and Earth climate science have become. This satellite uses a radar altimeter to measure the height of the oceans with centimeter-level precision. By comparing data over years, scientists can see how fast global sea level is rising as ice sheets melt and warmer water expands. They can track regional changes that affect coastal cities and shipping lanes. The launch itself was another routine but impressive feat for SpaceX. Falcon 9 lifted off, pushed Sentinel-6B into orbit, then returned its first stage to a downrange landing, adding another tick mark to the company's long list of ruses. For commercial space watchers, every successful reuse is another step toward cheaper access to orbit. For climate scientists, every extra year of continuous ocean data is priceless. But SpaceX is not the only company making moves. In the heavy lift market, Blue Origin is still working toward the first launch of its new Glenn rocket. The company has been testing hardware in Florida and upgrading ground systems, while executives talk about future versions with a more capable upper stage and higher performance for deep space missions. New Glenn is designed with a reusable first stage powered by B4 methane engines, aiming to compete with Falcon 9 and Falcon Heavy for large satellites and potentially crewed missions later on. Although the maiden flight has slipped several times, customers and analysts are watching closely, because once New Glenn is flying, launch capacity worldwide will jump further down the mass scale. Rocket Lab has kept up a steady tempo of launches with its Electron rocket. This week, Electron lofted a confidential commercial satellite from its New Zealand launch site, using its small but flexible launcher to fill a niche that heavy rockets cannot. Electron missions like this are part of a broader trend. Small, dedicated launches for individual customers who want a specific orbit at a specific time, rather than sharing a rideshare bus with dozens of other payloads. Rocket Lab is also developing its much larger Neutron rocket to compete in the medium lift class. But Electron remains a workhorse for smaller payloads and quick turnaround. All of these rockets, big and small, will be flying into a strategic environment that is changing fast. The United States Space Force has been finalizing a new roadmap that lays out what the service says it will need to operate in an increasingly contested domain. The roadmap, reported on this month, focuses on 3 big areas: space domain, awareness, resilient communications, and navigation. Command, and rapid launch, and maneuver capability. Base domain awareness is the military term for knowing what is in orbit, who controls it, and how it is moving. That means better radars, better telescopes, and better data sharing between allies and commercial operators. Resilient communications and navigation means building networks that can survive jamming, spoofing, or even attacks on individual satellites. That could involve constellations of many small satellites, laser links, and crosslinks that route around damaged nodes. Rapid launch and maneuver is where the rocket companies come in. The Space Force wants to be able to replace lost satellites or deploy new ones quickly in a crisis. That pushes demand for responsive launch services and for satellites that can shift orbits on their own. Whoa! All of this underscores a reality that runs through many of Today's stories. Space is not just a scientific frontier. It is also an economic and strategic arena. Now, before we wrap up, let us return to the sun, because our star has not been quiet. Solar Cycle 25 is ramping toward its peak, and the sun has unleashed a series of strong flares and coronal mass ejections this month. Space weather reports that these outbursts have caused radio blackouts, disrupted high-frequency communications, and sparked bright auroras at unusually low latitudes. For most people, the visible side of this is the light show. Social media fills with photographs of green and red curtains of light over cities that rarely see auroras. For airlines, satellite operators, and power grid managers, the picture is more stressful. When energetic particles from the sun slam into Earth's magnetic field, they can induce currents in long power lines and pipelines. They can scramble GPS signals and interfere with radio communication used by pilots and ships. Satellites can experience charging events and sensor glitches. The good news is that space weather forecasting has improved. Agencies like NOAA, NASA, and the European Space Agency run models that can estimate when a coronal mass ejection will hit Earth and how strong it might be. But as our society becomes more dependent on satellites and precise navigation, the stakes rise. This is part of why missions like NASA's Parker Solar Probe and the European Solar Orbiter matter so much. By flying through the sun's outer atmosphere and studying the origin of the solar wind, they help scientists understand what drives these big storms. Better physics leads to better forecasts, which leads to better protection for the systems we rely on. So, let us step back and look at the whole picture from this week. An interstellar comet streaks through the inner solar system, and we turn a network of spacecraft into a giant, distributed observatory to study it. A crew on China's Tiangong station returns home after debris damage forces extra checks, reminding everyone that orbital congestion is now a real hazard, not science fiction. SpaceX keeps stacking up launches, this time to watch Earth's oceans inch higher as the climate warms. Blue Origon's New Glenn and Rocket Lab's Electron show how many different kinds of rockets our era now supports. The US Space Force quietly writes a roadmap for how to operate in all of this chaos. And over everything, the sun throws off storms that can light up the sky and rattle our technology in the same week. On Think Cosmos, we like to say that space news is not just about astronauts and rocket launches. It is about the emerging weather system of our civilization. The traffic of satellites, the storms of the sun, the visitors from other stars, and the policies and companies that decide what we put up there next. As you listen to stories like these, try to imagine the timeline, not just in days or months, but in decades. The first interstellar objects we detect now are precursors to the era when we might send probes out to other stars. The debates over orbital debris today will shape whether Earth orbit is usable or dangerous 50 years from now. The choices we make about rockets, constellations, and space forces will ripple out through the century. For now, though, enjoy the fact that you are living at a time when a human-built camera orbiting Mars can turn, snap a photo of a visitor from another star, and beam it back to a screen in your hand. That is the kind of detail future historians of science will write entire chapters about. You are here for the first draft. If you found this deep dive useful, consider checking the official NASA and space agency pages for mission updates and sites like Space News, Space Weather, and Space Daily for ongoing coverage. Till next time, keep looking up. And remember, the universe is not quiet. It is talking to us in light, particles, and gravity. We just have to keep listening. Wow.